Hi, I'm Teacher Thomas. Welcome to math class. We're going to work through an example of a binomial expansion application. I'm given the expression 1 minus 4x times 1 minus 3x to the power of 10, and I need to find the coefficient of x to the power of 3. So my first observation is I have the binomial on the, well, they're both binomials, but the one that I'm going to be able to expand is the one with the exponent. And the one that doesn't have an exponent is going to affect the result in the following way. If I multiply 1 times something x to the power of 3, I will get something x to the power of 3. And in the case of negative 4x, if I multiply this by something x to the power of 2, I'll get negative 4 times some coefficient from the other term, x to the power of 3. So when I expand the 1 minus 3x to the power of 10, I need to pay attention to two terms. I need to find the one that has an x to the power of 3, and I need to find the one that has an x to the power of 2. And then we will come back to the left side and use those results to do the multiplications that I'm drafting on the left with precise values. And let me show in my first multiplication on the left, the x to the power of 3, there's going to be some coefficient, 1 from the 1 minus 4x, times some coefficient that I find from my expansion times x to the power of 3. So let's work on the right side. To begin, I'm going to set up a general, I'll set up my first term, maybe 2, and then observe, inspect, see if we can figure out where we'll find the terms that we need. My first term would be 1 to the power of 10. Then the next term will be 10 choose 1 times 1 to the power of 10 minus 1, which is 9, times negative 3x to the power of 1. Looking at these first two terms, again, noting in pink over on the left, I'm trying to find where I'm going to get an x to the power of 3 and an x to the power of 2. 1 to the power of 10 isn't relevant. There's no x term there. Now, the next term I have, notice where the x is. I'll put this in pink. Maybe it will be helpful, maybe not. That's going to be negative 3x to the power of 1. So that isn't going to be helpful to us. But what we can observe, notice that this 1 is the same as this 1. So 10 choose something is the exponent that we apply to the second part of the binomial. So with that, I can identify how I'm going to find my x squared term and how I'm going to find my x cubed term, and then I'll work with them. The x squared is going to be when I have that negative 3x to the power of 2. The x in the brackets is going to be exponentiated to 2, and that will produce something x squared. What are the other parts of that term going to be? 10 choose what? 10 choose 2. It's the exponent of that second term. Times 1 to the power of what? 1 to the power of 10 minus 2, which is 1 to the power of 8. And then similarly for x cubed, I will find that when I have the second term, negative 3x exponentiated to 3. And what are the other parts of that term? The binomial will be 10 choose 3, matching that second exponent. And 1 times 10 minus 3, 1 to the power of 10 minus 3, 1 to the power of 7. Now when I expand x squared term, I have 10 choose 2, which is, let me back up for a moment. There. Okay. Equals 10 choose 2 is 45, times 1 to the power of 8 is 1, times negative 3 squared is positive 9. Similarly, for the x cubed term, 10 choose 3 is 120, times 1 to the power of 7 is 1, times negative 3 to the power of 3 is negative 27. And on each of these I'll put the x on as well. In the x squared term, that x squared becomes x squared, which is what I'm expecting. That's the term, that's one of the terms I'm looking for. And then next, the x cubed is x cubed. And now I'll go ahead and simplify each of these. 405 x squared and negative 3,240 x cubed. Now let's go back over to the left, and I will mark in green for the x cubed term. What's going into this bracket? 1 times what x cubed? That's over on the right, negative 3,240. And in orange, over on the left, what's going into the x cubed here? Actually, that's going to be, I can fill it in there, but let's be clear, where that's fitting in is in the x cubed, x squared term. I have the pink box around the x squared term. There's some exponent there. And that exponent on the right side of the screen, not exponent, coefficient, excuse me, that coefficient is 405. On the left side, what I'm doing with these two calculations is I'm summing. So I'll write them out in full across the bottom, and then we can sum to our final value. We have the x cubed term is 1 times something x cubed. 1 times what's in green, negative 3,240 x cubed, plus the next result that produces x cubed is the negative 4x. That's coming from the binomial outside on the left, times what in green, excuse me, what in orange x cubed? 405 x, I said x cubed, 405 x squared. And now we can sum, we add these to negative 4,860 x cubed. And the question is, what is the coefficient? So the coefficient excludes the x term. The coefficient is negative 4,860. So summarizing the procedure, in the given, I see I'm going to be multiplying some binomial terms by 1 minus 4x. So I want to recognize that when I multiply by this 1, if I have an x cubed term, that will produce x cubed. And so that was the first setup that I did towards the top of the left side. And on the right side of the screen, I found what x cubed. When I expand my binomial, what x cubed? That was negative 3,240 x cubed. There's going to be another result that produces x cubed, which is negative 4x times something, x squared. Negative 4x times something x squared will also be an x cubed. So I look for, in my expansion, where do I have x squared? I found that as 405 x squared. And so I multiply that by negative 4x. We see all of those multiplications in the addition across the bottom. 1 times negative 3,240 x cubed plus negative 4x times 405 x squared. And the resulting coefficient is negative 4,860.